which is the little t. So think about if you drew a graph of what was happening. So, and we'll say this is 0. So let's say this is the temperature of 0. And then usually if you have, usually water in your house is usually about 120 degrees. Much more than that, you're going to get burned. So it's roughly there. So what happens when you turn on the faucet? So starts out cold, then it gets warm, okay? So it starts off, okay, we won't say it's necessarily 0, so it's somewhere in here, right? So it starts off at this temperature, basically whatever temperature is just sitting in the pipes, right? And then it starts off, and then slowly it will ramp up, right? And then what happens? It goes flat. You have your hot water, and it goes flat. Does it just say flat forever?
You can run out.
Can you run out? Okay, so eventually what happens? Eventually at some time, it slowly starts to go back down, and then it gets to some temperature, and then it just kind of goes forever, right? You see how that'd be a graph of what happens. Now, there are such a thing as, I don't have one, the endless water heaters. Does anybody have one of those? You can actually, they sell them where, they're more expensive, which is why not as many people have them. But basically you turn on the water and it creates instant hot water. So you basically could have like a hot shower for infinity. So it never would turn off. So the problem is with those is they struggle with, like if you have a house where like 2 people are showering at the same time, it struggles to give both people hot water. So that's the downside of that. So there's an example of a function, and this is, okay, we took the verbal description in words, right? And then based on what we know, we kind of came up with a graph of what that function would look like, right? That may be hard to find a algebraic equation that does something like that, but we could. All right, so let's say we have a function and we want to find the domain and range of a function. If you remember, the domain we think of as the x's, and it is the x's that work in the equation. So as you look at that equation, what values don't work? 1. 1 makes the bottom 0, right? See, 1 doesn't work. What about 0? Could you plug 0 in there? Because you get the square root of a negative. Side note, calculus has no imaginary numbers. There's no i's. Everything is only real numbers. So we never can have the square root of a negative. Now, can you do calculus with imaginary numbers? Yes. But unless you're a math major, that's like a junior, senior level math major class. So even if you're going to be like an engineer or something, you would never do that. And if you're not going into one of those, you'd never see it. So this, we can't have 0. That doesn't work. And we can't put 1. But really, anything bigger than 1 would work. Now, if we want to find the range is the y's. And the easiest way to find the y's is the range is to look at the graph. So if I look at the graph, this is 2 divided by the square root of x minus 1. And there, as you can kind of see the graph. You can see I cannot put anything less than 1 in, right? It's 1 and greater. But the question becomes, how high does this go? Does it stop? It looks like it stops at 1, 2, 3, 4, 5, 6, 7, about 8. Or does it keep going, but our calculator is just bad and doesn't show it to us? How could we determine that? One thing you can do is change the window. So I'm going to go in here to my window and say, let's go, I'm going to go higher 1. If I go to 15, does that change my window? 2, 4, 6, 8, 10. Not really. Oh, I did the wrong thing. I'm sorry. I want this to go to 15. If I do this 15, does that really change? Still looks kind of the same. But what I can do is if I change this from -1 to 5, does it go higher? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What if I make this go to 2? Does it go higher? Maybe I make this 0. You see how it keeps going higher? That tells me that this goes up forever. And who knows, if I go higher right here, I may be able to see even higher. So by just kind of changing the window, it gives you an idea. Go -0.5 to 1. Shoot, positive. Going even higher, right? So it keeps kind of going higher. So that tells us my range goes all the way up. This is going to be 0. Range is the hardest one. Range is hard. You got to kind of look at the graph to kind of figure it out. All right. Skip all this. All right. All right. The homework. 1.1 that was due today, it was just the one question, if you remember, which was the difference quotient. You can now do the rest of those. All right, let's go through these. Constant function, 2. Just. Horizontal line right at 2. My domain, -infinity to infinity. And the range is just 2. Because that's the only number you get out of it, is 2. Number 2 is a line. If it's just x, slope 1, y-intercept, all that kind of stuff. And then this. Absolute value, what's absolute value look like? The B. My domain is all real numbers, and my range is 0 to infinity. Square root looks like this. My domain is 0 to infinity, and that is also my range. Coming back to you, you look at this and you're like, oh yeah. Quadratic. X squared is a parabola, something like that. Domain is all real numbers. My range, 0 to infinity. X cubed, cubic, looks like that. And they're both So as we look at all these, it's not necessarily that you're gonna have to be quizzed on what these are. We'll just be using these function a lot, and so sometimes if you have an understanding of what they look like, it can just help what you're doing. All right, I think the back gets a little bit harder, right? These are a little bit harder functions on the back. First off, the reciprocal function. 1 over x just looks like this. And x cannot be 0, and y cannot be 0. You also could write it as like negative infinity to 0, 0 to infinity. You gotta skip over 0. The cube root function is kind of like the cube function, but it's on its side. And it's the same. I think I've never seen this before in my life, or okay. Come back to me. Read.
I've seen.
E to the x. What's that?
I've seen.
Do you remember e to the x? Thing on e to the x is goes through 1, but it goes like this. And the key to e to the x is its domain is anything. However, its range is 0 with the parenthesis. It never hits the x-axis. E to the x is never 0. It is never negative. Natural log, kind of the inverse of e to the x, looks like this. And these flip. Its domain is there. And then finally sine and cosine, and we're going to spend a couple days on trig later on, maybe the end of this week or so. We'll see when we get there. So sine looks like this. Cosine looks like that. Thing to remember is sine starts at 0, cosine starts at 1. They both have the same domain. And they have the same range. Do I have? So as we talk about graphs, do we remember how we can move graphs? So, this we're just going to do here. If we have a graph, do you remember what does the +2 on the outside do? Moves it up. So we would take that graph and we move it up, which would then look like that, right? Take that graph from the right and move it up. If we have -1 inside, that moves it left or right. right 1, right? It's the opposite. It's minus 1 you move. So you move it to the right 1, so it would look like so it would look at like that. If we had x plus 2, that would move it to the left 2. So it would be over here. If you had minus 2 plus 1, that's going to move it to the right 2 and up 1. Now here's how I would do that one. I would think of like this. I think of like those 4 points. And I think, okay, that point here is going to go right 2 up 1. Right 2 up 1. Right 2 up 1. Right 2 up 1. To kind of get. And if you remember, a negative inside flips it over the y-axis. A negative outside flips it over the x. So this is going to flip this over the y-axis and then move it up 3. So it flips it over the y-axis and goes up 3. So it's going to go to here, flips it over the y. 3. Now, what we want to do is take those movements, those transformations, and combine them with our parent functions. Remember. So, square root of x minus 1 plus 2. So, you know the square root. You have your parent function sheet in front of you, but we know that. Now, we know this is going to move it right 1 up 2. So we know our normal shape and goes right 1 up 2. So we get something that looks like that. Gotta do these one at a time. Try the next one. You try the next one. I'll give you a chance to try it. And then we will. X plus 2 quantity squared minus 1. It's going to be, think of what our quadratic is. We're going to go left 2, down 1. Absolute value. The negative x outside flips it over the x. Negative 2 goes down 2. E to the x minus 2. Negative 2 inside moves it to the left or right. Here's one way. It's a little bit different. Think of it this way. Here's how I think about it. What would make the inside 0? 2, right? So that tells you it's going to go to 2, which would be to the right. So what makes it 0? So this is going to go 2 right. Normally e to the x goes through here. And e to the x is a hard one because it doesn't have a whole lot of points we know. We just kind of know the basic shape. Kind of goes like that. The square root, we kind of know the basic shape of square root. The negative inside flips it over the y. And then the plus 2 makes it go up. And then the last one's got a little bit of everything. We go to the left 1. Usually we start here. It goes to the left 1, down 1, so we move down to here. Normally, it goes like that, but the negative out front is going to flip it and